Hello, everyone. Thanks for tuning in today. What we have on store today is a classic transmitter receiver design. It's called the Pixie. Some of you may have heard of it. It may be new to others. And the Pixie is a very unique little circuit in that with just two transistors, we build a radio transceiver. That's not just a transmitter, but a transceiver. And the way that works is a very um, unique, very ingenious, actually, uh, use of circuitry. Here's our bias resistor for our output transistor, and we're going to have a inductor here. This is about 100 microhenry. This can be a 2N3904. And this here should be for 40 meters, about 15 to 22 microhenry. And this part right here is the key to the whole function. It's both a receiver and a transmitter. And the key to that lies in this point here that's called a magic bus. We have a ground here, a 0.05 microfarad capacitor here, which I'll explain later, and a bias resistor for this transistor on the emitter of 10K. But they're pretty high emitter resistance, and you see the reason for that is because this is actually a receiver. The antenna connects here to the collector, and it goes through a cap and a pi network, and that goes to our antenna. There's our pi network. These are both 820 picofarad capacitors. And for 40 meters, this should be about 22 microhenries. Now, the way this works is very unique in that we have this magic bus right here. And this goes down traditionally in the Pixie circuit to an LM386 amplifier. However, for this circuit, we're going to be substituting that with a chip called a TDA2822. It's still an 8-pin chip. However, it has two amplifiers. It's a stereo amplifier, and the reason for that I'll get to here in a minute. Now, in the traditional Pixie, this right here would go to our key. And that allows us to broadcast Morse code. And the way that allows us to broadcast Morse code is because we have an oscillator over here. And that oscillator sends a signal to this, which acts as a modulator when we have the key down. However, when we don't have the key down, this mixer circuit right here, this oscillator right here, allows this to act as a mixer because the emitter here is floating through this 10K resistor. It's not floating, but it's pulled down through a weak resistance. And so what we have here is basically a common well, let's put it this way. We have a collector coupled amplifier. Our collector coupled amplifier works like this. We have the signal coming in through the collector. We have our mixer circuit here. These two signals get mixed, and the output here results in RF. RF has two fundamental components. It has the sum and the difference of the input frequencies, and the sum and the input are going to be the sum and the input, the sum and the difference are going to be well, let's finish drawing our circuit here. There we go. There. Now we've got our basic, there's our oscillator. Now, anyways, getting back to this, the sum and the difference here are going to be RF frequencies. And at RF frequencies, what's going to happen is this capacitor right here is going to filter those RF frequencies, and it's going to react to the envelope of the signal coming in, which means it's going to, this is amplitude modulated signal coming in. Amplitude modulation looks like this. And what this capacitor does is it smooths the output. And this right here, these are the sum and difference frequencies from our mixer. However, what we get out of it is the lower frequency audio. And that audio appears here on our key signal. And therefore, we get sound. When we click the key down, what happens is it bypasses this K resistor right here. And now we have the emitter coupled directly to ground, and that pulls a lot more current through this transistor. And so this transistor outputs the oscillator signal. Then we have a basic means of broadcasting Morse code, you see. So this is both a Morse code transmitter and a Morse code receiver. This is the very traditional Pixie circuit. What we have in store today is a simple, unique alteration of that basic circuit, because we're using a TD2822. And what we're going to do here is we're going to modulate this. You see now the output of this, because this is powered from our 12-volt power supply, and this over here is also powered from our 12-volt power supply. Now, in practice, we'd probably want to put a choke here and a nice fat capacitor right here, something like 100 microfarad, which works out great because this capacitor here is also 100, and this capacitor here is also 100. So there, we're minimizing the use of different components. This is a 0.05, because this is a 0.05. No other reason. You see consolidation of components. Let's put our 3.3K here to bias our transistor, and let's put an 82, well, let's put 100 picofarad here. And these two here are 100 as well. 100 picofarads, that is. And that loads our crystal, which should be about 7.04 megahertz for the 40 meter band. You're gonna want to choose something a little different than that, because 7.04 is CW only. But in the higher portion of the 40 meter band, you're allowed to use voice modulation as well. So this circuit lends itself well to both of those. Now, what we're going to do here is we're simply going to make this key switch we're going to take this off to a double pole, double throw switch. And with that double pole, double throw switch, you see, what we have here is we're going to ground this line right here so that we don't have our microphone feeding back and modulating the signal while we're trying to receive something. It just mutes this microphone input basically. And this right here will be floating at half of the 12-volt power supply, which is about 6 volts. That 6 volts powers our circuit when it's in receive mode, and it does a fine job as a receiver. And then when we key this, when these switches go into transmit mode, you see, now our magic bus here is grounded and our input is unmuted, and we're able to broadcast audio using a Pixie transmitter and transceiver. And this is basically the classical circuit with only one refinement, and that one refinement is that we've used a stereo amplifier, and we've incorporated part of that stereo amplifier as a modulator for our mixer circuit, our output stage. So there you go, a basic Pixie. Well, here, let's finish this up just in case someone's taking notes. That's a 47K resistor. You can find this circuit online. It's really common. And you can incorporate these notes into the circuit that you find online, or I'll put a link in the description for a more detailed guide on how the Pixie works. And you can refer back to this video if you should decide to build the circuit. It's a really simple circuit. If you're into amateur radio, there's no reason at all not to give it a go. And I hope that you really get some enjoyment out of it. That's all for today, and thanks everyone for checking in.